1.2, we're going to talk about substitution. So just a recall of linear systems again. Okay, a linear system is when we have two or more linear equations. So if you take a look here, it just says line. Linear equation is just a line. And we have to consider these at the same time. So here's an example. If we consider y equals 2x plus 1 and y equals 3x minus 1. Okay, so the method of substitution, this is when we solve a linear system by substituting for one variable from one equation into the other equation. Okay, so up until now, so in grade 9 and in 1.1, what we did, or what we had to do, is we had to take these equations and we had to actually graph them. Okay, so let's try that first. So for the first equation, okay, the b and the slope. So the b was 1 and the slope was 2. So we'd go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. Okay? And that's how we would have to solve. And then for equation 2, which is y equals 3x minus 1, we would have to do the exact same thing. Start at -1 and go up 3 over 1. Up 3 over 1, 1, 2, 3, up 3 over 1. Okay? And we would have to graph these to find the point of intersection, and then just simply look at the POI, which in this case is 2, 5. Okay, now we're going to take a look at substitution, and to take these two equations and solve for the point of intersection solely algebraically. So the steps to substitution. First, what we're going to do is we're going to isolate a variable, okay? We're going to recognize that substitution is the way to go if there is a variable, let's just say x, that has a 1 in front of it, or like an x obviously by itself, because then it just implies that there's a 1 in front of it, okay? Or if we had a y by itself, or even a negative y, because we can get that alone very, very quickly, okay? It gets a little complex when we have something like a 5y. Okay, we want that y by itself. So we're going to isolate for a variable, and then we're going to substitute the expression into the second equation, collect like terms and solve. Then we're going to, and at this point, we're going to have x equals a number, or y equals a number. Okay, and then we're going to sub that number back into one of the original equations to solve for the second variable. Okay, sounds really confusing, but it's actually a very, very quick process. Okay, so let's go ahead and find the coordinates for the point of intersection of these two equations. When I look at these two equations, I recognize immediately that the x and the y have no number in front of them. So the number in front of them is 1. Let's work with this. So let's just bring the y over, and we'll be left with x equals 5 minus y. Okay, so we're already done the first step. We isolated a variable. Now we know that x equals 5 minus y. So if we were to take this expression right here, let's go 5 minus y, and we were to plug it into the second equation exactly where the x is, this is what it's going to look like. We're going to have the 3, and then in brackets, we're going to have the x, which is 5 minus y. And we have minus 4y equals 7. And then now all we have to do is collect like terms and solve. Okay, expand this, we get 15 minus 3y minus 4y equals 7. Okay, we can collect these, I get negative 7y. We can bring the 15 over, we get 7 minus 15, which I get negative 8. Okay, we need the y by itself still, so divide both sides by negative 7. I get y equals 8 over 7. So that's one of the terms. So we solved for the variable. Now all we have to do in the last step is take that variable and sub it back into either one of the equations. And just to recall, we know that when we're looking at a linear system, the point of intersection is common for both equations, so it doesn't matter which equation we choose. I always like to choose the easier one. The easier one will be x plus y equals 5, this one right here, because then you're not dealing with the 3s, the 4s, and the 7s, right? So we can do x plus y equals 5, and this y right here, 8 over 7, we're going to sub it right into where the y is. X equals 8 over 7, x plus 8 over 7 equals 5, and then we just bring that over. X equals 5 minus 8 over 7. You can put that straight into your calculator, and I get x equals 27 over 7. Okay, so then we can say, therefore, the point of intersection is x, which is 27 over 7, comma, y, which is 8 over 7. Okay, now let's just practice. Okay, example 2, find the coordinates of the point of intersection of these two equations. Okay, so immediately when I look at these two equations, I want to figure out which one's going to be the easiest to isolate. We have a negative y, so that's pretty easy to isolate, and we have a y, which is even easier. So I'm going to leave the y on this side, and I'm going to bring over that 4x, and we're going to get y equals 9, and then the 4x changes to negative 4x, and that's what we're going to deal with. Okay, so now we have an expression for y. I'm going to sub this expression, 9 minus 4x, right into where the y is in the first equation. So we can bring this down. 2x minus, and then what's y? 9 minus 4x equals 4. Okay, don't forget that this negative sign distributes into both terms in the bracket. So we have negative 9, and then it's going to be plus 4x. Okay, so we have 2x plus 4x. I get 6x. And then we can bring this 9 over, and it becomes positive 9. So 9 plus 4 equals 13. Okay, and now all we have to do is divide by 6. And I get x equals 13 over 6. Okay, well, here's a little bit of a hint on the y. So instead of subbing in x equals 13 over 6 into one of the originals and then recalculating, if you are very confident with your rearranging abilities, then we can actually sub it right into this equation here, because we already isolated the y. So we already have an entire equation to represent or to express y. So y equals 9 minus 4 times 13 over 6. If you want to do this the long way, I get 9 minus 52 over 6. And I get y equals, and again, if you have a decent calculator, then you can just put this into your calculator, 1/3. Okay, and therefore the point of intersection of these two lines is 13 over 6, comma, 1/3. I'm going to quickly show you how to check this. What you want to do is you want to take this point of intersection and you want to sub it into equation, let's call this equation 1 and equation 2. So if you have 2x minus y equals 4, what you want to do is you want to sub in the 13 over 6 and then minus 1/3, and then does that equal 4? So we have 26 over 6 minus 1/3. Does that equal 4? If you put this into your calculator, you're going to get 4. Therefore, this point satisfies the first equation. And you also want to check the second equation. You want to make sure that you didn't just find a point that satisfies the first equation, but also the second equation. Oops. So what you want to do is you want to sub in the x and the y again, and we're going to get, it's going to be 52 over 6 plus 1/3. And if you do this in your calculator, you are going to get 9, and therefore you can check on every single test and assignment that your point of intersection is correct. So for this one, I notice immediately that the x just has a negative on it and the y just has a negative on it as well. So I can isolate for either of these very, very easily. Okay, so let's bring that x over so we have x equals something. Okay, so we're going to leave the negative y on the left-hand side, and we're going to bring over that 6, which is negative 6. Okay, so this is what x equals. So we're going to take that equation, 4x, but instead of writing x, we're going to write negative y minus 6 plus 2y equals 8. Now distribute in, I get negative 4y minus 24 plus 2y equals 8. Okay, negative 4 plus 2y, I get negative 2y. And this negative 24, I'm going to bring it over, and it becomes positive 24. So 24 plus 8 is 32. And we're going to divide both sides by negative 2. I get y equals negative 16. Okay, so that worked out nicely. Is kind of like a cheat if you trust your algebra and you want to actually use the equation that we already isolated x for. So instead of actually subbing in y equals negative 16 into one of the originals, sub it into the one that already has x by itself. So we have negative y, which is negative 16, minus 6. So then that would equal positive 16 minus 6, and I get 10 equals x. So therefore, the point of intersection is 10 comma negative 16. All right, and let's use substitution in a word problem. So Dylan works for guaranteed pool repair. He charges, so let's say C is the cost. Okay, so he charges $50 for a service call plus $40 an hour for labor. So this is Dylan. And H is going to be number of hours worked. Okay, Chris, so this is going to be Chris, works for Oasis Pools and Spas, and he charges $30 for a service call plus $45 an hour for labor. So let's, the question says, find the length of a service call for which both Dylan and Chris charge the same amount. Okay, so when we look at this question, the same amount, we want to know when they equal. Okay, and then what we're going to do after is when is it more advantageous to go with Dylan or with Chris? So let's do same amount first. We have two equations. If you can see, the C for this equation and the C for this equation are actually already isolated. So let's sub in 50 plus 4H right into this C. We can just set these two equal to each other. So 50 plus 40H equals 30 plus 45H. Okay, bring that 30 over, I get 50 minus 30, which is 20. And this is 45H. Bring that 40 over, I get 5H. And we're going to divide both sides by that 5. So I get H equals 4. So at 4 hours, both of them are going to cost the same amount of money. And let's actually just solve for how much money that is. 50 plus 40 times 4. 50 plus 160, it's 210. So at 4 hours, both of them are going to cost $210. Now, I always do like a little visual in the corner for this. Oops. There we go. There we go. So Dylan starts at $50 and then goes up, right? And Chris starts at 30 and then goes up. And we know the POI is 4,210. So less than 4 hours. So when the hours is less than 4, we should go with the 30, which is Chris. And when the hours are greater than 4, we should go with Dylan. When the hours are equal to 4, it doesn't matter.